Welcome back. I've got a quick and hopefully easy project for this video. I purchased this Stahlwille socket set second hand on the New Zealand equivalent of eBay. The listing showed only one picture, close up at the tray and sockets, which looked good at the resolution it provided. The seller described the set as excellent condition. The socket set is a mixed SAE Imperial and British Whitworth set. I'd guess from the 70s or 80s. I purchased it primarily to carry around in the Land Rover, as those are the two standards used throughout the vehicle. Now, Stahlwille, of course, is made in the mighty country called Germany. Germany is the best in the world at a couple of things: music and socket sets. So I was pretty excited to receive my excellent condition Stahlwille socket set. Then this trashed old socket set showed up in the post. So clearly you can see the case is rough. It's bent up, filthy, and has been repainted with grass green coloured paint at some time in the past. And the plastic tray is a little sad. A few of the sockets have chipped chrome, and overall they are well used, but generally in decent condition. However, 3 of the sockets have been chamfered on a bench grinder for, well, I don't know why you would do that, but somebody has anyway. First job is pretty easy. I dunk everything in mineral terps, which I think is called white spirits to the rest of the world. After the grease is loosened, everything goes into the ultrasonic cleaner for a quick blast. With everything clean, I split the sockets into 4 groups. First, the sockets that have been attacked with a grinder. Second group are sockets with chrome chipping. Third, sockets that are okay but have small defects that I may address but don't really need to. And the fourth group are perfect as is. Here is the first of 3 ground sockets mounted in the lathe. The process is pretty simple. First, I take out the grinding marks with a smooth file. There is such a thing as a lathe file, which may help, but I find that even the smooth file leaves gouges when used on the lathe. I think because build-up tends to sit in one spot and scratch the surface. So I find it a bit much to go straight to sandpaper. Instead, I blast it quickly with an orbital sander. The result is a rough but even surface. And then it's just a matter of going through the sandpaper grades, starting at 180 grit all the way through to 2000. I repeat the process for the other 2 sockets. You can see how well they polish up. If you look really close, you can see the transition from chrome through copper to base metal. It's important for this next step that the metal is surgically clean. I start by wiping the sockets with paint thinner, and then a cycle in the ultrasonic cleaner. I'm going to replace the missing chrome with a brush-on electroplating product. In electroplating, the solution contains the salt of whatever metal you want to plate. For example, for nickel plating, you use a nickel sulfate solution. The nickel component flows with the electrical current out of the solution and onto your part. That's the gist of electroplating. This solution is copy chrome. It's not real chrome. Real chrome uses chromates that are extremely carcinogenic. Plus, chromates can't be shipped through normal couriers. I expected this solution to be cobalt based, but the label says nickel sulfate, so I guess it's nickel with a bit of something else to get the colour close to the correct colour of chrome. Straight nickel has a gold tint. Normally in electroplating, the part is suspended in the solution. and the current is run through a sacrificial anode of the same metal as the solution. The difference here is that there is no sacrificial anode, so the metal is drawn out of the solution but not replenished, and instead of dunking the part, the current flows through a soaked piece of fabric. Because of this direct route, the plating builds up in seconds. I say seconds, but I don't really know because the kit came with no instructions. I can just barely see the change in colour where the reaction occurs. And there we are, not bad. In fact, the only issue is that the new plating is more chrome-like than the original. For all of the small chips, it's the same process, just localised. Next, I think we'll deal with the case. First, as with everything that needs restoring, it gets a scrub. I noticed that the paint around the Stahlwille logo was still the original green. A while back I prepared a test swatch of the paint I'll be using, so here's an opportunity to see if we're in the ballpark. Here I'm just roughing up the paint. This is optional, but it will help the paint stripper work. Once the stripper has had a few minutes to work, I go outside and quickly wire brush most of the paint away by hand before neutralising the stripper with the garden hose. It takes a couple of applications to get near enough to bare metal. Next, I use a rotary wire brush to clean up the remnants. Obviously not this old wire brush, it's an eyeball stealer. I splash out on a nice new one. The case is twisted. The back has been pushed in while the front overhangs. There are a number of dents and twists. It looks as though somebody has used it as a stepping stone. Eventually I get it to the point that it closes nicely all of the way around and the worst of the dents are taken out. It's not completely straight, but good enough for a socket set. I will do some filling. I don't apply bog directly to metal or fresh paint. I know some people do and that's fine, but I prefer to prime and sand before filling. This is the paint. Hammerite green. It's the closest colour I can find in a hammer finish. It's not perfect, but pretty close. I think the real colour has a slight blue tint. Normally I use Rust-Oleum hammer paints in a spray can. They are great. It's easy to achieve an even hammer finish and the paint cures fast. I couldn't use Rust-Oleum spray cans because I live at the end of the world. Nowhere in New Zealand could I find green Rust-Oleum or even Hammerite paint in a spray can. Hence I had to purchase a tin. That's bad because this is some gloopy paint and I'm not sure I'll be able to spray it. You can't thin it with conventional thinners because Hammerite contains silicon, which creates the hammer effect, and regular thinners mess that up. Day 1. I sprayed the insides first. It went okay. I could just get the gun to spit the paint out good enough to work. So long as you get the paint on thick enough, the hammer effect takes over and the surface evens out. Day 2. I don't know what changed, but the paint was just too gloopy to spray. I persisted with spitting paint at the case for a while before I resorted to a splash of mineral spirits to thin it down. It worked in the sense that it made the paint possible to spray, but even just a small splash had an effect on the hammer pattern. And 3 days later, the Hammerite paint is still curing. I do not recommend this paint. Now for the Ratchet, the thing that makes a socket set way more awesome than spanners. This Ratchet is probably more than 30 years old, and it feels like it. It works fine, but it's a little bit crunchy compared to a nice new version. And I think that's exactly what I'll do. I'll replace it with a nice new version. The steel handle version of the current Ratchet looks like it will sit perfectly in the existing tray. But for now, let's have a look inside. With the pinion removed, you can see the pawl. The pawl is angled so that the Ratchet will skip past in one direction, but be forced into the pawl in the other direction. Yep, it's just those two little teeth that take all of the force. In this case, the pawl is held in place by an interference fit pin. I have no reason to take this apart, but for the sake of science, let's do it anyway. And this is what you pay for. This is an old Ratchet that has seen a hard life, and the teeth of the pawl are in excellent condition. Pull apart a cheap Ratchet and you'll see wear on the face of the teeth. Unfortunately, one of the teeth of the pinion gear has been damaged by a heathen, but otherwise the teeth on both are excellent. The pin that goes through the pawl is bent, which may affect how smooth the backspin feels. I've got a couple of other Ratchets here, so let's have a look inside and see how they compare. The Stahlwille Ratchet is a 36 tooth Ratchet, giving it a minimum stroke of 10 degrees. Second, a branded Ratchet that I purchased new about 12 years ago. I won't mention the brand because it's irrelevant. It comes from Taiwan or maybe Japan, out of a generic factory that would have been manufacturing and selling tools to all sorts of brands. The third Ratchet is made by Right tool. There are basically two Ratchet designs. This and the Stahlwille Ratchet are the same, having the pawl in the body of the handle. In fact, this is a blatant copy of the Stahlwille Ratchet, almost to the millimetre. Also a 36 tooth Ratchet. It's a lot newer than the Stahlwille and has a much lighter backspin, which I prefer. They've peened over the ends of the threads to stop people getting in. Well, that won't stop us. So this Ratchet has been frequently used for about 12 years, not in a professional environment, but often. I'm pretty easy on my tools, so it'll be interesting to see what it's like. I'll point out that this was by no means cheap. Most people would consider this to be a premium brand. You can see how ridiculously similar they are, but here's the difference. This ratchet has seen a fraction of the use that the Stahlwille ratchet has, and yet there is clear wear on the face of the pawl teeth. Now, moving on to the right tool ratchet. This is not a generic tool. Like Stahlwille, Right Tool actually make their own tools, and in the Western world. Right Tool is up there with Snap-on, but more for hairy folk who work in mining and the oil industry. This wrench is interesting for two reasons. Firstly, it is the other way of making a ratchet, with the gear cut into the body of the wrench and the pawl on the inside as part of the pinion. Secondly, this wrench has 45 teeth, 9 more than the other two wrenches. But this particular wrench has another trick. It has 2 pawls, and they are offset by half a tooth, effectively making the wrench a 90-tooth ratchet, resulting in a swing of about 4 degrees. The wrench is almost brand new, so we're not going to see any wear on the inside. Back to the Stahlwille. Before reassembly, I took the time to blacken the black parts. I went through this process in depth during the Myford restoration, so I will skim over it here. The last major component of this little project is the sagging tray. These things always sag and crack, but I have a fix for that. I must admit that I've only ever done this before on small areas, like cracking corners. First, I have to hold the tray in its final state, so that means holding it flat to the bench. I faffed around for ages trying to get this to work. Eventually I covered it in double-sided tape, more than you can see here, and it stuck. Well, it did for a while. And here's the trick. Builder's expanding foam. Yeah, this is not really a restoration technique, but it'll sort out your cracking socket set tray. Once it sets, it'll hold the tray in shape, and the excess can be easily cut away. I realised at this point that the tape was starting to come unstuck. I can hardly go back now, so I just had to weigh it down. When the foam is cured, it can be easily cut away with a knife. You can actually just tear it off in chunks by hand if that's easier. This knife is a bit pathetic. What I need is a
Ginsu 2000.
Better.